This is the video for section 6.4, and we're going to talk about vectors and dot products. You probably don't have your book with you, but on page 422, they give you a good example of when you would use dot products. They show you a picture of a semi going around a hill, and you can use dot products to find the force necessary to keep a truck from rolling down a hill. So on this first part, we're just going to do basic properties we're going to use basic properties of the dot product and just do basic math for you to get used to it. And then the next section, part 2, we'll be doing some word problems and see how they actually apply. So the first thing we're going to talk about is the definition of a dot product. If I have, and on your paper you may not have the symbol for a vector around your ordered pairs, so if you don't have that, you'll need to fix them. But the dot product of u and v, okay, it's real easy. You just multiply your first two numbers in your u and your v, or that's the horizontal components, and then you're going to add u2 times v2, which is that would be your vertical components. And then they also list some properties of the dot product. Let u, v, and w be vectors in a plane or in space, and let c be a scalar. So they tell us that u times v is, or the dot product of u and v is the same as the dot product of v and u. Okay, so it has that commutative property, just like multiplication. 0 and v, the dot product of 0 and v gives you 0. And this kind of looks like the distributive property, but on number 3, and that should be, yeah. See how the dot product is the same as the dot product of u and v plus the dot product of u and w? It's kind of like distributing. The dot product of v and v is the same thing as finding our magnitude squared. So you find it's kind of like v squared. And then my scalar times the dot product of u and v, again, this right here, cu, the dot product of this, okay, equals u times the dot product of that scalar in v. Okay, so I'm going to show you what that all looks like. So I want to find each dot product, and again, I should have these symbols around here for each one of these. All right, so I want to find the dot product. That means I'm just going to multiply my first numbers together, so 4 and 2, so 4 times 2 plus 5 times 3. So 8 plus 15, the dot product is 23. On part B, 2 times 1, I'm multiplying this and this together, plus -1 times 2. So 2, that's going to give me -2. The dot product is 0. On this one, 0 times 4 plus 3 times -2. So I have 0 minus 6, so the dot product is -6. Okay, so the dot product of two vectors, these are two vectors, is a scalar, which are these numbers. And the dot product can be positive, it can be 0, it can be negative. Okay, it doesn't matter. So let's look at the next thing. Now we're going to use the properties of dot products in order to find a and b. So I know that u is this, v is 2, -4, w is 1, -2. Find each dot product. So on A, I'm going to find the dot product of u and v first. So here's u, here's v, so that's going to be -1 times 2 plus 3 times -4. That gives me -2 minus 12, which is -14. And now I'm going to take this answer, because this is -14, and I'm going to multiply it by w. So I have the scalar being multiplied by this vector. So that's going to give me the vector negative 14, 28. Okay, and that's my answer. On this, u times 2v, there's a couple of ways you can do this problem. I'm going to find 2v first. All right, so 2v, I'm going to take my vector v and multiply it by 2. So that's going to give me 4, negative 8. And now I'm going to take u. So u is negative 1, 3. And I want to find the dot product of that and 4, negative 8. So that's going to give me negative 4. I'm going to write it out for you. Negative 1 times 4, because I'm multiplying my first numbers together, plus 3 times negative 8. So negative 4 minus 24, so my answer is a scalar this time, negative 28. All right, so pretty easy stuff. Example 3, this time I may sometimes want to find the angle between two vectors. If theta is the angle between two non-zero vectors u and v, then cosine theta equals the dot product of u and v over, I'm going to be multiplying the magnitude together of u and v. Okay, so find the angle between 4 and 3, between these two vectors. So first of all, let's see what they're talking about. If I graph the vector 4, or the vector u, 1, 2, 3, 4, 1, 2, 3. So 4, 3, there's the vector u. 3, 5, 3, 5. Here's the vector v. They want this angle in between those two vectors. So it says I can find the angle by cosine theta equals. I need to find the dot product of u and v. So let's do that first. The dot product would be 4 times 3 plus 3 times 5. So that's 12 plus 15. So I know that top part, this part right here is 27. And I'll fill all that in a minute. I need to find the magnitude of u, the length of u. Remember, that's the same as the distance. So u, that's going to be 4 squared plus 3 squared, 16 plus 9. So that's going to be 5. The magnitude of v is going to be 3 squared plus 5 squared, or 9 plus 25, which is the square root of, what is that, 34? So now I'm going to plug all that, okay, into, I know what my dot product is, I know what magnitude of u is, magnitude of v, magnitude of v. So I'm going to have, let me change colors, cosine theta equals u, my dot product of u and v, which is 27. Magnitude of u is 5 times the magnitude of v, which is square root of 34. Now, I need to know the actual angle. So I need to do second cosine to find the angle. So in my calculator, first of all, let's make sure that we're in degrees. So I'm going to hit second cosine of 27 divided by 5 times the square root of 34. And theta is 22.166. 22.166 degrees. So now we know how to find the angle between two given vectors. Okay, last thing we're going to talk about is a definition, the definition of orthogonal vectors. Vectors are, I can't talk, vectors are orthogonal if their dot product is 0. So that's pretty easy. Are the vectors u and V orthogonal. So we're going to find their dot product. It's 2 times 6 plus negative 3 times 4, 12 minus 12, 0. So yes, they are orthogonal because of the fact that their dot product is 0. Okay. Um, the terms orthogonal and perpendicular mean essentially the same thing. They meet at right angles. Okay. Um, so if I were to graph this just to show you, oh, that is really bad. Hang on a second. Okay, let me graph these two vectors. Whoops. Let's get a line over here. It's not much better, is it? Okay. So if I were to graph 2, negative 3, so 2, negative 3, there's U. And 6, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. There's V. I kind of missed it a little bit, but that's okay. All right. They meet or they form a right angle. Okay, so that's what orthogonal means. And you can tell whether they're orthogonal, whether their dot products equal 0 or not. Okay, your assignment for this is page 429. You're going to do 1 through 10, 11 through 27 odd.